Okay, our last problem. And again, I said I was going to pick a couple that looked really familiar. If I was the AP, I would, grab a problem like this where you're given a table. Hot water is dripping through a coffee maker filled with a large cup of coffee. The amount of coffee in the cup is given by a differential function C. So this is not a rate function. This is actually the amount of coffee. So it starts at 0 and is 5.3, what is it, ounces. Then it gets up to 14.5 ounces, so on and so forth. So it says use the data in the table to approximate C prime of 3.5. So C prime is the derivative. So we want to know the derivative of this. We're approximating 3.5. So we don't have a spot at 3.5. We want to wait calculate derivative. So to estimate, we'll choose the point before and after. So we're going to use slope. C of 4 minus C of 3 divided by 4 minus 3. And we get, as you look at the data here, we have 12.8 minus 11.2, which equals 1.6. What ounces per? And in this table, we are measured time in minutes. So, it says indicate the units of measure, which we did. This just means that the coffee at that time is, it's increasing by a rate of 1.6 ounces every minute. Okay, easy enough. Part B. Is there a time at which the derivative is equal to 2 over 2 to 4? Okay, so is there a time which the derivative is equal to 2? Well, let's find the rate of change from 2 to 4. So if we go C of 4 minus C of 2 over 4 minus 2, see, C of 4 is 12.8 and 8.8. So we got 12.8 minus 8.8 over 4 minus 2. So we get 4 over 2, which is 2. So we came up with that. So the idea is that, here's the idea, okay? We're, say we check a point there and point there. We say, well, this is our average rate of change. Is there a spot where we also have that rate of change? Yeah, it's right here, okay? And so, that's the mean value theorem. So if the average rate of change comes out to be something that's a differentiable function, which it says it is, then it has to have a value too. So mean value theorem guarantees C prime of t equals 2 over the interval 2 to 4. Okay, so mean value theorem is going to guarantee that, which is a nice deal. Okay, so invoking the mean value theorem, very important. Problem C. Use the midpoint sum with 3 subintervals to approximate the value from 0 to 6. So if we're using 3 subintervals from 0 to 6, that means the width of each one is 2. So 0 to 2, 2 to 4, and 4 to 6. And it says use the midpoint, okay? So what we do is we do 1 over 6 times the integral 0 to 6 c of t dt. So that's going to be 1/6 times. Now we have the width, which is going to be 2, and then we have the height, which is 5.3, plus 2 times, then the height here is going to be 11.2. And then in this situation, we have width of 2 and a height of 13.8. Now, they did not give you a calculator on this problem, but we're going to use it. I think that they're going to allow you to use calculators. So we had 2 times 5.3 plus 2 times 11.2 plus 2 times 13.8. Notice I could have factored out that 2 if I wanted to. Divide that by 6, and I get 10.1. 10.1 ounces. Now, it says, what does that mean? Okay, well, this is the average value function. It means the average amount of coffee. And if you look here, does it make sense that the average amount would be about 10.1? And I would say, yeah, it looks like that's reasonable. the average amount of coffee from time equals 0 to time equals 6. I'm going to put minutes just in case they get picky. Is 10.1 ounces. Okay, so we've explained what that means. And question D. The amount of coffee in the cup in ounces is modeled by this actual function. So these points come from this function right there. Using this model, find the rate at which the amount of coffee in the cup is changing when time is equal to 5. So we're looking for the derivative. B of t is equal to 16 minus 16e to the negative 0.4t. And we're wondering b prime of t. Well, the derivative of 16 is 0. And then this, I'm going to use the chain rule. So I have negative 16e to the u, and I have negative 0.4t. Derivative of negative 0.4t is negative 0.4. I go ahead and take that derivative, negative 16e to the u. So multiply those, I get a positive 4e to the negative 0.4t. So 4e to the negative 0.4t. It says it wants to know at time equals 5, b prime of 5 is equal to 4e negative 0.4 times 5. Negative 0.4 times 5 is negative 2. So 4e to the negative 2, or 4 over e squared. Now what is that? That is ounces per minute. Let's check our answer key. So our last one. Just want to make sure I'm doing these right. I stumbled on a couple earlier, and I totally screwed up. Because if you take 0.4 times 16, you don't get 4. You get 6.4. Sorry about that. 6.4 over e squared ounces per minute. So mistake there. Sorry about that. Otherwise, everything else looks like it is spot on. There's your last problem. I'd love to be able to go through all the 2019 problems with you guys. There's 4 or 6 of them. Take us about an hour and a half, I think, to work through. Have a great day.